Exercise 6. We're going to name compounds containing polyatomic ions. So yes, we have to know what the names of these polyatomic ions are. This is why it's so useful to memorize key polyatomic ions and then additionally to memorize those 3 patterns, because it just helps you out so much. So again, I'm not going to write the answers in here because there's just not enough room. You guys, because I'm trying to at least keep a little bit neat as you guys go, you guys can take notes and annotate wherever you want. Use the entire page because this is for you. But as we go to give the systematic name for each of the following compounds, we have A, right? So this is the sulfate, right? The sulfate polyatomic ion. Definitely want to get used to that being sulfate. There is sodium right there, so that's sodium sulfate. Looks good. This is the phosphate ion, but then there's this weird hydrogen here. There's a weird hydrogen here. And so this is a little bit tricky. This is actually the entire polyatomic ion. Right? It's not just phosphate, there's this hydrogen as well. Because remember, polyatomic ions, they're typically all non-metal elements. Oxygen's a non-metal, phosphorus is a non-metal. Remember, hydrogen is a non-metal, even though it's over in group 1A. And so the name of this polyatomic ion is dihydrogen phosphate. It's the phosphate with 2 hydrogens, so dihydrogen phosphate. What's the metal? What's the cation in front of it? Potassium. So the full name is potassium dihydrogen phosphate. Then we have nitrate. We have the nitrate polyatomic ion, right? And that's iron. Iron is a transition metal. It's going to form multiple cations. So we need to say, using Roman numerals, how many charges are on it. I look at that nitrate, and I see that there are 3 nitrates. Nitrate has a -1 charge. There are 3 of them, so that's a total of -3 charge. That must be offset by a +3. So this is going to be iron 3 nitrate. Here's a hydroxide. Right? Here's a hydroxide paired with manganese. Hydroxide has a -1 charge. There are 2 hydroxides, so that's a total of -2 charge. And so the single manganese atom must provide those 2 charges. So that's manganese 2 hydroxide. Here's the sulfite polyatomic ion. See how it has 1 less oxygen than the sulfate? So this would be sodium sulfite. Here we have the carbonate polyatomic ion, right? And if you remember a joke I made last year, if this is carbonate, what would the name of this be? It would be carbonite. That's what Han Solo was frozen in. So sodium carbonate. And then I get into this kind of same pickle I was here on B with the potassium dihydrogen phosphate, because there's this hydrogen here. So yeah, this is carbonate, but there's this weird hydrogen here. So this is actually the polyatomic ion. So it's carbonate with a hydrogen. So I'm just going to say hydrogen carbonate. What's the cation there? It's sodium. So sodium hydrogen carbonate. We talked about perchlorate as one of the examples of one of the patterns that we want to be familiar with, right? So this relationship of sulfite and sulfate, ite and ate. There's the perchlorate. This is cesium perchlorate. Now here's a tricky one, because if you look on a polyatomic ion sheet, you're probably not going to see that. You will see this, right? That is hypochlorite, right? Hypochlorite. So don't let this throw you off. Don't let this throw you off. How these are flipped like that, because in terms of the structural formula, the sodium is bonded to the oxygen, and the oxygen is bonded to the chlorine or the chloride, and so it makes sense to draw it like this, right? To write it like this. But when you go to look up the name on a polyatomic ion sheet, you're not going to see this. This is hypochlorite. So this substance is sodium hypochlorite. And then we have selenium, right? And selenium forms a couple different polyatomic ions. it turns out that there actually is a polyatomic ion of selenium that has more oxygens than this. So this would be sodium selenite, right? Because selenate would actually have more oxygens than this. So this is selenite. And then lastly, we have bromate. Bromate. That's bromine. It's the oxyanion of bromine. So bromate. And then potassium bromate.